In this video, we'll be looking at complex compound or coordination chemistry. These are subtopics under this complex compound. Meaning of complex compound, the characteristics of complex compound, meaning of central metals. Then the meaning of ligands and the types of ligand. We have video on how to calculate oxidation number of central metals and naming of complex compound with their rules and regulation. Now let us look at this meaning of central metals. The central metals refers to the metal atom or ion that is bonded to one or more ligands. When you have a central metal, typically made up of transition metals or post-transition metals, such as lactinide and actinide. The lactinide and actinide in periodic table and F block, and also D blocks. The element that falls under D blocks and F block are majorly used as a transition metal, as a central metals in complex compound. That's why I said the central metals is typically a transition metal or a post-transition metals. So if you want to know the typical example of this complex compound, just let's look at this example. You can see that in this, I have a PT, which is platinum, in the middle, which bonded with the 2 chlorine and 2 ammonia. So these are examples of complex compound. Now examples of complex compound transition metals are here. We have chromium, manganese, iron, copper, and so on and so forth. Then the post-transition metals are lactinium, rutherfordium. All those ones are under post-transition metals. Now, the meaning of complex compound. Complex compound, also known as coordination compounds, and are chemical compounds that consist of central metal atom, e.g., nickel, iron, aluminium, platinum, zinc, majorly, all the D and F block elements, or ions surrounded by ligands, which are atoms, ions or molecules that donate electrons to the metal. The characteristics of complex compound. The first thing is coordinate bonds. The coordinate bond. Complex compounds contain one or more coordinate bonds which are linked between 2 electrons, where one atom donates both electrons. If you look at these examples here, the ligands attached to the central metal are donating electrons to the metals in the middle. The next one is charge. Complex compounds can be neutral or charged, and charged complexes are stabilized by labeling counter ions. That is, just keep it in mind that the central metals, or let's say complex compounds, can be neutral or charged compounds or complex, because so far that the ligands are donate electrons to the central metal, typically they are going to be what? They are going to be charged. If they want to be neutral, it means that they are going to have neutral ligands. We are still going to the ligands to know which ligands are neutral, which one have charges. So because we have ligands as well. Other characteristics are we have geometries. Central complex compounds also are what? They have a geometrical. They are geometrical in nature. We can have trans, we can have 6 in naming of complex compound. Another that we also have tetrahedra, square planar, and octahedra. So they have geometries. Then we have isomers. Under isomers, we have the 6 and trans. So all these are the characteristics of central complex compound. The uses of complex compound. Complex compound have many uses, including oxygen transport in blood. The way the hemoglobin is moving the oxygen around the body. Water purification, we use it in water purification, also in the pharmaceutical companies. Also to determine of central metal color, because when the ligands attach the central metal, it displays some rows in color. So we also determine the color of central metals in the complexes. Meaning and types of ligands. Ligand is an atom or ion. Even it can also be molecule that donates one or more pairs of electrons to a central metal atom or ion, forming a coordinate covalent bond. That is, by the time the ligand donates the electrons to the central metal, as I've said before, it's going to form covalent bond. So we have many types of ligands. We have monodentate ligands. Bind to this monodentate ligand, you have just like one teeth to attach or bind themselves to the central metal. Examples of monodentate ligands are the halogen families, chlorine, fluorine, iodine. They are monodentate ligands. Another example of monodentate ligand is H2O. H2O also is a monodentate ligand. Then ammonia as well, NH3. We have bidentate ligands. Bidentate ligands, they bind to the central metal through 2 atoms, e.g., ethylene diamine. Examples of bidentate ligand is ethylene diamine. They have 2 ways to bind themselves to the central metals. By the time you go to the rules and regulation in naming the complex compound, you'll get to know the meaning of all this. We also have polydentate ligands. They bind to the central metal through multiple atoms. Examples of this one is ethylene editor that we call ethylene diamine tetraacetic acid. Then we have abidentate ligands, which can have different ways like cyano, then thiocyanato. All those one are ligands that you're going to come across soon in naming the complex compound. Then let's look at the ligands with their charges, because there are some ligands that they are neutral. Why some are they have just one charge, like -1, some have -2. If you are given the complex to name, nobody will tell you that this ligand is neutral ligand. This ligand is just -1 charge ligand. This ligand is -2 ligand. No, you'll be the one to master all these ligands with their charges. Now, ligands that are neutral, that is, they have zero charge. Examples of them is water, H2O. And if you want to name water in ligand in a complex compound, we say aqua. Another neutral ligand is ammonia, NH3. We call it amine with AMMINE in spelling. So it is neutral ligand wherever you see it. It has zero charge, doesn't have any charges at all. Another examples of neutral ligand is carbonine, capital letter C and capital letter O. Combination of oxygen and carbon is also a neutral ligand. The next one is a nitroxy, is a neutral ligand. Another one is a phosphine, is a neutral ligand. Then we have menin, even ethylene diamine, which is EN. Ethylene diamine is also a neutral ligand. Another one is a pyridine. We use PY to represent that. Is also a neutral ligand. Tetrahydrofuran is also a neutral ligand. So wherever you see any of these ligand in complex compound, keep it in mind they have zero charge. Examples of ligands with just -1 charge are all the halogens family: chlorine, bromine, iodine, fluorine. They are neutral ligand. Then hydroxyl, which is a hydroxy group, they are -1 charge ligand. Then cyanide, we call it cyano in naming, it's also -1 charge ligand. Then bidentate ligands, under there are some bidentate ligand that they have just one charge. Examples of that one is a polydentate ligand or salacto. Whenever you see O2 minus, O2 2 minus, they are under these examples. Then other ligands that are abidentate, cyanocyanato, SCN, or we can also have it as NXC, is also monodentate ligands with one charges. Now, examples of ligands with the two charges, we have oxide, sulfide. All this one, whenever you see them, they have two charges. Then we have aceto, carboxylate ligands, and then other ligands like carbonato, cyanato, uh, they have two charges. Now let's look at this video to know how to name the complex compound. Today class, in this class we're looking at naming of complex compound, also called complex uh, chemistry. Now we have many rules that guide these complex compound, but as we are naming the compounds, those rules I'll be explaining it one after the other. Now keep this in mind. We have many ligands, so which I have explained in my previous video in this on top. You will see it there that we have ligands, those with a neutral charge, with a just one charge, with two, and so on. So now keep it in mind. I repeat some of it here, which we have neutral ligands. So if you see amine, if you see carbonyl, when you see H2O, called aqua. When you see Pi, which is pyridine. When you see PPH3 and EN, cyclopentadiene, all these one are neutral ligand. They have no charges at all. We also have the ligands with just one charge, which are all halogens family, be that iodine, chlorine, bromine. Then we have CN, which is cyano. Then ACAC, acetanato. Then SCN. This one is the abidentate ligand, and or we have it as NCFs. All these are um, ligands with just one charge. Then we have the one with two, CNO2, CO3 2 minus, O2 minus, X2 minus. So all this one, they are ligands with two charges. So in case if you come across them, nobody will tell you in your exam. So you really want to know the ligands from each other. The one with zero, the one with one, the one with two, and three, and so on. So now let's begin to name some of these examples. I come across some of these questions in past questions of some of your friends. Now let's start with number one, solution. We have the parentheses, and here we have the central metal, which is ion, in brackets Cn into bracket 6, and the parentheses were closed. See, if you want to name complex compound, the first thing you have to do is that you generate the oxidation number for the central melter. Now, don't forget, in complex compound, we have about 4 things. When you have something outside the parentheses in your right, it is called cation. When you have something outside the parentheses, like at this side, which is your left, we call it anion.
So it's possible you can have charges on top, be that minus or -1, be that plus, +2 to any length. So have all those things in complex compound. We have rules that guide them in naming. So we are going to treat treat them one after the other in this um, note. Now let's name this one. Let's first generate the oxidation number of ion. So the oxidation number first. Oxidational number of Fe, which is ion. So you know that this one is Fe plus, cyano, Cn, it is monodentate ligand. So it has one charge. Just say open bracket -1 times 6 is equal to 0. Then you continue. Fe minus times plus times minus, you're going to have minus. Then 1 times 6, you have 6 is equal to 0. Then cross equal to Fe is equal to plus 6. So this is how I come across this question, which I believe that you cannot have a oxidation number for ion to be 6, but let's take it that way. Now, if you want to name it, you first name the set. If you don't have anything outside the bracket here at your left hand side, then you are going to name the ligand first before you name the central metal. So this one will now be hexa because 6 is hexacyano. Hexacyano. Now, this one you will not call it ion. You say ferrite. We derive this one from the Latin name of ion, verum. Hexacyanoferrite 6 in Roman figure, Vi. So this is the name of this. Let's try the number 2. Fe into bracket H2O, close the bracket in 6 place 6. Then you close the parenthesis, then SO4. Now, if you look at this one, it's a little different from the first one. So don't forget, whenever you have something outside the brackets at your right hand side, you call it what? Cation. So they also have their charges. If it's halogen, all halogens they all have one charge, which is -1. But this one it has -2. So keep that in mind. SO4 is -2. So now, to get the section number of this Fe, just Fe plus open bracket H2O. It is neutral ligand. Say 0 times 6 plus open bracket -2 is equal to 0. Now Fe plus 0 plus times minus, which is -2. So Fe plus O plus 0 minus 2 is equal to 0. So when you cross multiply and you multiply times, you're going to have Fe is equal to 2. End of the day. So to name this one, you start from the ligand because you don't have an ion here. You just say hexa. You will not say water. So we call H2O aqua in complex compound. Hexa aqua. Hexa aqua. Then you name this one. Now, here, you will not say ferrite. You have to say ion. Whenever you have cation outside the bracket. Hexa aqua ion 2. Because we have 2 for oxidation number of ion here. Ion 2 sulfate. So this is the name of this one. Let's try the number 3. So this one is CO open bracket NH3 close bracket to 5 place 6, then Cl, then Cl2. This one is almost the same thing with the one we just name now. So now to name this one, you have to calculate the oxidation number of cobalt. CO is cobalt as under normal elements. When we have the difference between, look at this one. We have CO and CO. Whenever you have capital letter C and capital letter O, that one is carbon, a combination of carbon and oxygen. But whenever you have C, capital letter C and small letter O, that one is cobalt and elements. So take note. Now this one is the cobalt, CO, capital letter C and small letter O. Now to get the oxidation number of this one, just say CO plus amine is a neutral ligand, NH3. So you just say open bracket 0 times 5 plus chlorine, it is neutral ligand. You say it's a -1 ligand, -1 times 1 because it is 1 here. Plus, we have another chlorine outside, which is also -1, but it is 2 here. You say -1 times 2, -1 times 2 is equal to 0. So this will now be cobalt plus 0 minus 1 minus 2 is equal to 0. Everything here will now be cobalt minus 3 is equal to 0. Then you have cobalt is equal to 3. End of the day. So to name this one, we'll now start with, you will first name the ligands. And whenever you have multiple ligands, you have to name them alphabetical order. Chlorine and amine. Amine will first come before chlorine. So you start name from the amine by saying penta because we have a 5 amine there. Penta amine. That amine is 2N. Penta amine. Then you name chloro. Then chloro, it is 1. Chloro, just say chloro. Cobalt. Cobalt 3. Cobalt 3 chloride. So this is the name of this one, pentamine chlorocopper 3 chloride. So let's continue with number 4. Okay, this is K4, open the parenthesis, FeCN into 6, place 6, then we close parenthesis. Now, if you look at this one, it's different from the other one. It asks something outside the parenthesis. So in case when you have something like this, it's very simple. Just remember, most things that they always put at the back at the beginning of parenthesis, they are majorly main group elements, like group 1, group 2, group 3 elements, are always outside the parentheses. And remember, group 1, group 2, group 3 elements in periodic table. Group 1 will donate 1 electron to become electropositive. Group 2 will donate 2 electrons to become 2 electropositive. And group 3 do the same thing to be 3 electropositive. Now, remember, potassium is in group 1. So it is plus 1. So it is not minus here. You just say 1 times 4, not minus 1, plus Fe. Then plus, open brackets, cyano, it is minus 1 ligand. So you say minus 1 times 6 is equal to 0. So from here, you're going to say 4 plus Fe minus 6 is equal to 0. So if you are to collect the like times, this will now be Fe is equal to 0 plus 6 minus 4. So Fe is equal to 2. So the oxidation number of this ion here is 2. Now to name this one, whenever you have something like this, you will first name the one at the beginning of parenthesis before you name the ligand, followed by the central melter. So now to name this one, don't include their numbers, just mention their name by saying potassium. Potassium, then you name the ligand hexacyano. Hexacyano. Ferrite, use ferrite now. Ferrite 2. Ferrite 2. This is the answer for this one. Now, let me name the one that has multiple ligands. Let me try this one, which is number 5 now. CO, one bracket, H2O into 4 places, then NH3, Br2, we can also have I2, close the bracket, then SO4. We can have something like this. Now let's try to name this. Before we are going to name this, we have to generate the oxidation number of cobalts. Now let me tell you something clearly. Whenever you are dealing with written in this type of chemistry, you are to show your oxidation number by working it out. But if you are dealing with CBT, quickly use fast method to get your oxidation number, then you name the compound. But if you are dealing with written, make sure that you get your oxidation number out clearly. Now let's find the oxidation number of cobalts here, which is CO plus aqua is water, which is 0 times 4 plus 0. NH3 is 1 here, so it is neutral ligand as well. It is 0 plus, open bracket, minus 1. Bromine is minus 1 times 2 because it is 2 here. Then plus, open bracket, minus 1. Iodine also is minus 1 times 2 because it is 2 here. Then plus SO4, it is minus 2. Everything is equal to 0. Now, let me now try to do something. Okay, let me leave this one this way. I continue. CO plus 0 times 4, it is 0. Plus 0 minus 2 minus 2 minus 2 is equal to 0. So everything will later be cobalt minus 6 is equal to 0. Then later, you're going to have cobalt is equal to 6. Now here, to name it, I'm going to say, first look at ligands. We have how many ligands? 1, 2, 3, 4. So we have aqua, we have amine, we have bromine, we have iodine. So you are going to follow the alphabetical order to name this one. So you start with the aqua is AQ, amine is AM. So amine will first come before aqua. So this will now be amine, tetra, aqua, di, bromo, di, iodo, di-iodo. Then you name the cobalt now. Cobalt. Then you put this in brackets. 6. Cobalt 6 sulfate. So when you have this in different, like you have many ligands, so try to use alphabetical order to generate their names. So this is how to calculate or to get the name for this one. So the next one will be, now let's try this again. You will see that this one is asks Aeon on top. So let's try to name this. Let's get the association number for cobalt. Now here you have cobalt as CO, and you also have carbon as CO as well. If you look at the difference now, carbon is capital letter, the C is capital letter, the O is capital letter. Why cobalt, the C is capital letter, why O is small letter. So this is elements, and why this one is compound. Now let's name this CO plus. Carbon is a neutral ligand, just says open bracket 0 times 6 is equal to, whenever you have something on top of this, you have to say equal to that thing. If it is plus, if it is minus, we say minus of that thing. So that's how it's supposed to be. Then you are going to have this to be CO plus 0 is equal to 3. Then CO is equal to 3. To name this, you will just say hexacarbonene, hexacarbonene, cobalt 3 ion. So this is another rule there. Whenever you have anything on top of the parentheses, you have to indicate the name at the end to be ion. Cobalt 3 ion. Cobalt 3 ion. So if it is minus, same thing as ion. If it is plus, same thing as ion. When you have such, so take note of that. Another example, which I'm going to use abidentate ligand. Let's try this. Fe, open brackets, XCN, close the brackets, 6 raised to power minus 4. Now, to name this, first get the association number of ion, Fe plus SCN, it is it has a -1 charge, just open brackets, -1 times 6, then equals to -4. You have -4 on top. So this will be Fe minus 6 is equal to -4. So at the end of the day, you're going to have Fe is equal to -4 plus 6, then you have Fe is equal to plus 2. Final answer. Then to name this, I want you to remember that cyano, FCN, is a abidentate ligand, an abidentate ligand. So when you have such, if S first come to be XCN, it means that the compound is binding itself to the central metal with sulfur. But when you have it in the form of NCS, that is N first come, it means that N is binding itself to the central metal, which is a ion. So if you want to name this, it has rules. Just do this. Say hexa. This compound is COC anato. COC anato. COC anato. Hyphen. You put X. Hyphen. You name the, because it is X hyphen ferrate 2. Put ion. Ferrate 2 ion. But if it is N that first comes to be NCX, you have to say hexacylcyanato hyphen N hyphen ferrate 2 ion. So that's the rules that guide this. If you have abidentate ligand. Now let me try to name one, and I'll call it a day. Cu, open brackets, En2, SO4. This is copper. Then you try, in case if you don't have anything here, copper it will be cuprate. Same thing. If it is CO, it will be copperate. So take note of those things. Now let's try to name this. Cu plus En is called ethylene diamine. So ethylene diamine is a neutral ligand. So you will just say 0 times 2 plus one bracket minus 2, because SO4 is minus 2 is equal to 0. So then you get this to be Cu plus 0 minus 2 is equal to, at the end of the day, you're going to have Cu is equal to 2. So it's very simple. Then to name this, just say bis. The reason why I say bis here is because ethylene diamine, it has di already. Don't say ethylene diamine. Even if it is 3 that you have here, say trees. And you have 4, you say tetris. So this one will be bis, open brackets. You now say ethylene diamine. Bis ethylene diamine, copper 2 sulfate. That is the answer. Bis ethylene diamine, copper 2 sulfate. Now let's look at the another way around for this course. If you are given the name, that you should write the complex out, like write the structure of the following inorganic complexes. Number 1, potassium tetracyanonical 3, bis cyclopentadiene ion 0, bis cyclopentadiene ion 3. So tetra amine bromoiodo ion 3 chloride. Trish ethylene diamine ion 3 bromide. Potassium hexacyanoferrate 3. So we are given this now to write the structure out. Now, if you want to do this, it's simple. But you have to take note of anion and the cation. Whenever you have the anion that started the name, like potassium, like sodium, like lithium, that one will be at the beginning of the parenthesis. So like, look at this one now, potassium tetracyanonickel 3. So potassium you first start the compound. K, then you open your parenthesis. After you open your parenthesis, you go back to the compound, the name of compound. You look for the central metal first. In the parenthesis, the first thing in the parenthesis is central metal. You look at the parenthesis, the name, look at the central metal, nickelate, which is Ni, nickel, capital letter I, N, then small letter I. Then look, the next thing is your um, ligand. You open the small bracket, tetracyano. Cyano is Cn. Close the bracket. Tetra is 4. You put 4 here. Now, if you want to know whether this is correct, you find the oxidation number of nickel. If it is same thing with the 3 that you have here, definitely you are correct. But don't find the oxidation number inside your booklet. You find it separately in a rough sheet. If I have to find the oxidation number of this one now, it will be potassium is 1. So you have just say 1 times 1 plus cyano is minus 1, then it is 4 here. Minus 1 times 4 is equal to 0. At the end of the day, if I have to do this one, I'm going to have 1 plus Ni minus 4 is equal to 0. If I have to collect the light times, I'm going to have Ni is equal to 4 minus 1. So, and Ni is equal to 3. Definitely, this thing is correct to be K, open bracket Ni, in bracket Cn, 4. That is potassium tetracyanonickelate 3. So, when I get the oxidation number of nickel, I find it to be 3. So, this one is correct. So, the number 2. This is bis cyclopentadiene ion 2. When you hear the word cyclopenta, now to look at this, bis cyclopentadiene ion 0. So if you just look at it, bis cyclopentadiene, don't worry about this bis. It means that cyclopentadiene is of 2. So you can see that it has diene. That's why they use bis. Not to say dicyclopentadiene, no. So now cyclopentadiene, it means that a ring that has a ring of akin that has 5 rings is called cyclopentadiene. So if you want to do this, just say draw the 5 rings. 1, 2, 3, 4, 5. So you put double bond here, double bond here. This is cyclopenta. Then you put Fe. You draw another cyclopentadiene. So this is the structure of bis cyclopentadiene ion 0. So let's try it now. In case number 3, let's try to name this number 3, bis cyclopentadiene ion 2. If you have that like bis cyclopentadiene ion 3 and ion 2 that is not 0, or they say ferrite 2, just try to open a big parenthesis like this and put that number, which is ion 2 or ion 3 or ion what, ferrite 2 or ferrite 2, ferrite 3. Just try to put the number on top here. Like, let me try to name the one that looks like that. Let's say you have something like bis cyclopentadiene ion or ferrite. Let me say ferrite. Ferrite 2. Now, if you have something like that, just say Fe then you have a big parenthesis like this. You put the number here, which is 2. You put 2 here. 2 plus. So this is how that one's supposed to be. Now, if you want to name this, look at this one. Tris ethylene diamine ion 3 bromide. So when you hear the word ion 3, so the central metal have already come as ion 3 before you now hear the word bromide. It means that after the parenthesis at your right hand side there is another bromine, or it can be sulfate, it can be chloride, anything. So now, if you want to name this, just try to open your parenthesis. Now, ethylene diamine, first look at your the central metal, which is Fe ion. Then you open the small brackets. Ethylene diamine, it is En in short way. Then they put 3s. It means that ethylene diamine it is 3 here. Then you close the parenthesis. That is only one ligand that we have. Outside this, we have bromide. Then you put Br. So if you want to know whether this 3 is correct, you have to calculate the oxidation number. So if you have to calculate the oxidation number now, you know that En, ethylene diamine, is a neutral ligand. 0 times 3 is 0. And this one is minus 1. Cross equal to, it will be plus 1. So, and we have ion 3 here. It means that bromine here, it is not only 1, it is 3. If you want to know, try to calculate the oxidation number for this, then you are going to get your answer to save the time. Now, let's move on. Let's try number 5. Look at this. Bis bicyclo.
Oh, yeah.
Let's try another one. Let's try tetra imine bromo iodo ion free chloride. So look at this now. Tetraimine, bromo, iodo, ion 3 chloride. After the ligand, which is ion, we still have another cation, which is chloride. So it means that after the parenthesis, there's something. So, and there's no anion that started this naming. So you open your parenthesis first. The first thing inside the parenthesis is your central metal, Fe, which is ion. Then you have tetraimine. You open small brackets, you put NH3. This is imine. And tetra is 4. You put 4 here. Bromo, iodo. Then bromo, it is Br. Iodo is capital letter I. Then you close the parenthesis. Chloride, Cl. If you want to know whether this is correct, you calculate the oxidation number for this compound. If it's the same thing as these three, then it is correct. So look at this one now. NH3, it is neutral ligand. 0 times 4 is 0. Br, it is plus only 1. We have 1 here. It is minus 1 times 1. Iodine, minus 1 times 1. Chlorine, minus 1 times 1. So minus 1, minus 1, minus 1, it is minus 3. Cross the equal to, it will change to plus 3. Then at the end of the day, you're going to have Fe is equal to 3. So this one is correct like this to be tetra, imine, bromo, iodo, ion 3 chloride. Now let's try this. Potassium hexacyanoferrate 3. Potassium hexacyanoferrate 3. So if you want to name this, you will see that ferrate comes. It means that nothing is outside the parentheses at your right. But here you have potassium. Once you have all those main group elements started this name, it means that before the parentheses there's something. So you have potassium, which is K. Open the parentheses first, and next, then you put your central metal, which is ion, Fe. Then followed by ligands, hexacyano. It means that you open small brackets, cyano is Cn, hexa means 6. Then you close the parentheses. Now, let's try to calculate the oxidation number for this to know whether we're going to put something here for K or not. Now, if you are to put something here, calculate the oxidation number now. You know, this will be 1 plus Fe plus open bracket minus 1 times 6 is equal to 0. So this will now be 1 plus Fe minus 6 is equal to 0. End of the day, you're going to have Fe is equal to 0 plus 6 minus 1. So Fe is equal to 5. Meanwhile, in this place, you have ferrate 3. It means that this case is supposed to carry a particular number. So which number are you going to subtract from 6 that will give you 3? It means that this K is supposed to be 3 here. You know, when I try 1, it gives me 5, and I'm supposed to have 3. If you try 2, you're going to have 4. And if you try 3, you're going to have 3. So this case should be K3 open bracket parenthesis Fe Cn6. So this is how this one's supposed to be.
Now, these are the past questions that I came across. In case if you have any complex compound question which you want me to help you out, you can put that in the comment section. You can even snap it and send it to the comment section. I'm going to find time to name it for you. And I want you also to ask question in case if anything is not clear under this topic. God bless you all. Thank you.